In this lesson, we're going to be working on a lot of different examples of kinematic curves. In other words, we're going to be looking at the position time graphs, the velocity time graphs. We're going to be looking at motion maps and the word descriptions of motion. I'm going to use this time with you to go through and do a couple of examples on each section of this worksheet so you can follow along and then do the rest on your own for practice. All right, so let's start with problem 1. We're given the position time graph. We want to sketch the corresponding velocity time graph and motion map. I'm going to choose example number 3 here. So in looking at the position time graph, the object starts at a position of 0. So I'm going to come down here to the motion map first, and I'm going to start with my first dot there. If you look at how the slope of this graph changes over time, as we work our way up the graph or over time, the slope gets steeper and steeper. That tells me that the object is moving faster and faster. It covers more distance every second of time. So that means the dots on my motion map are going to have to spread out farther and farther every second. And when I connect them with arrows, you can see how that distance gets bigger and bigger every second. Now let's go back and draw the velocity time graph. The slope of the graph at this point is pretty small, almost 0. And maybe a middle point, the slope here is a little bit larger and positive, and here it's very large and positive. So my velocity time graph is going to look like that. The velocity increases over time. In question number 2, it asks us to write the verbal description of this motion. So for number 3, I would start out by saying the object begins at a location of 0. It travels in a positive direction, and its speed increases, or its velocity increases. And another way to say that is that it has positive acceleration. Okay, so you try that with the rest. Now in this next set of problems, you have still position time graphs, but you have 2 types of motion going on. So we want to think about them in 2 separate ways. Look at the first segment independently of the second segment. Okay, so I'm going to do number 6 for you here. What I see in the first segment here is that the object remains at a position there, whatever value this represents on the y-axis, for a certain amount of time. If an object maintains the same position over time, the slope of that segment is 0. That tells me that the object is standing still. So I'm going to put my velocity time graph there on the 0 value on the y-axis for velocity. Now let's take a look at the second segment. Beginning at this dotted line, what happens is the same thing that happened in problem number 3 above. The object starts out at a specific location, and then as it moves, the curve here gets steeper and steeper. That's telling me that the object is getting faster and faster. So in terms of velocity, my value has to go from 0 up. And I know that it's a positive velocity because the position here on the y-axis are positive values. So when we write the verbal description, we will say that the object stays still for the first segment. Then we'll say it speeds up in a positive direction for the second segment. Okay? Now, what we're after is our position time graph, our velocity time graph, our motion map, and our verbal description to all tell the same information. You should be able to describe the motion or imagine the motion of an object from any of these pieces. Now in number 3, it asks us to sketch the position time graph, which we've done, and then the velocity time graphs. Okay, so this time you have the motion map. I'm going to do number 4 this time. Start with the motion map and sketch the 2 graphs that go with it. So I'm going to start with the position time graph. This object starts at a location that's to the right of the origin. This line here represents the origin. So I'm actually going to start my position time graph somewhere in a positive location. And this object travels to the left, which is a negative direction. But you see how the dots are getting closer and closer together? These arrows are getting shorter and shorter. That tells me that the object is slowing down. So I need the slope of my position time graph to become flatter or less steep. And what that's going to look like is this. I've got my object in a positive location. It's traveling towards 0, which is to the left on the motion map, and the slope is getting flatter and flatter because it's slowing down. Then to draw the velocity time graph, I'm going to think about the slope of this position time graph. I start out with a pretty large negative slope, so I'm going to begin my velocity time graph here, and I end my position time graph with a pretty flat line, which has a slope of 0. So I'm going to take this graph for velocity time to 0. And that's how you draw the information on the graphs from the motion map. In number 4, we have the verbal description, and we have to sketch the corresponding position time graphs. So I'm going to do number 5. It says the object is stopped at the origin for a few seconds. So at the origin is at a position of 0 meters, and if it's stopped for a few seconds, it's going to stay at that same position. You can put one of those dotted lines down through here if you need to, the way the last question was, like that had 2 segments. And it says then it moves away at constant velocity. So I'm going to have it move away in a positive direction, and that's a straight slanted line because it tells me it's a constant velocity. So if I come down here to do my velocity time graphs, if the object is stopped, look at the slope of the position time graph. It's a flat line. That tells me it has a velocity of 0 meters per second. And then look at the slope of the second segment of motion here. You have a straight slanted line with a positive slope. So I'm going to draw my velocity time graph as a constant positive value there. Let's keep going. This is oh, this brings me to the end. Yay! Okay, so at this point, I've done one of each of the examples with you, and so I hope that helps you get started on all of these problems. Do what you can, and if you have questions, we'll talk about it next time. Good luck!